We continue looking at how to construct the graph of this function. We've seen where the numerator is 0, we've seen where the denominator is 0, and we've marked up the graph accordingly. So we know where the zeros are, and we know where we expect to find the vertical asymptotes. Now, we want to understand also what happens when x is very large, whether positive or negative, when x is a large number. So, if we have a large positive x, much greater than the greatest zero of the numerator denominator, we're wanting to look at what happens as we go this way on the x-axis, what happens to the y value. Does it get big? Does it approach zero? How does it change? And we're dividing one quantity by another here. We could end up with a quantity that gets big, we could end up with a quantity that gets small, or we could end up with a quantity that approaches some value. Okay, so some fixed value. Now, we want to consider large positive x, and we've got to consider much greater than the greatest zero of the numerator or denominator. Now, the zeros run from negative 4.3 to plus 5, about negative 4.3 to plus 5. So, we want something bigger than that negative 5 to plus 5 interval. So we're going this way. We could try x equals 10. Somebody, of course, this is a class summary, that was suggested. X equals 10 is greater than x equals 5, so it'll give us an idea. Although it's not that much greater, it's still worth evaluating. So if x equals 10, you can verify it. The numerator is equal to 585, the denominator to 153, so that y is 585 over 153. Now that's close to 4 because 585 is close to 600, 150, 153 is close to 150, and 4 times 153 would be 600. That's a mental calculation you should be able to make. In any case, that's close to 4. Now, I say, okay, x equals 10 is greater, but not that much greater, so let's try x equals 100, which is greater. It's more greater. I won't say it's much greater. 1,000 or 10,000 or a million would be much, much greater. But this is going to be greater enough to give us a result. So this is going to work. Okay, so what's y if x equals 100? Well, we don't need to get the exact value of y. We just need to get a value that we're confident is pretty close so we can see what's happening to the values of y. Are they getting really big? Or are they getting really small? What's going on? So what we do is we say, first of all, the numerator consists of factors x plus 3, x minus 1, x minus 5, and x minus 3 is 103, x minus 1 is 99, x minus 5 is 95, and every one of these numbers is close to 100. None of them differ from 100 by more than about 5%. So we expect that the product will be close to 100 times 100 times 100, which is 1,000,000. Again, you should be able to do that in your head, 100 times 100 times 100. So that's the approximate value of the numerator. I should put approximate here. But that should be good within a few percent. Okay? Numerator is not going to be much different than 1,000,000. What about the denominator? Well, we can evaluate the denominator a little differently. Let, again, x equal 100, and we're going to get 100 squared, which is 10,000. So x squared is 10,000. The 5x is 500, and 3 stays 3, so that x squared plus 5x plus 3 is going to be 10,503. What's that close to? Well, you should think about what that's close to. Well, it's close to 10,000. Okay? So that y, which would be the numerator over denominator, approximately equal to 1,000,000 over 10,503, is still approximately equal to 1,000,000 over 10,000, which is 100. Now, when x is 10, y is about 4. When x is 100, y is about 100. So we get the idea that y is getting big. Now, so it looks like large positive x is going to give us a large positive value of y. Now what about a large negative value of x? Well, let's try negative 100, since 100 worked pretty well for us. I didn't work through the details. You should work through the details. Negative 100. Okay, all these will be near negative 100. Negative times a negative times a negative is negative. 100 times 100 times 100 is still a million. So we're going to get negative a million. And it's going to be over, as I get this, we get approximately equal to this. We can easily evaluate x squared, which is still going to be 10,000. 5x for x equals negative 100 is going to be negative 500, and then we're going to have plus 3. That's going to give us 9,503, which is close enough to 10,000 to say that, okay, when x is negative 100, we're going to get negative 100. Or something very close to negative 100. So that gives us an idea of the end behavior. The end behavior being that for large positive y, large positive x, we're going to get a large positive y. For large negative x, we're going to get a large negative y. That's going to help us construct this graph.